I think I'm recording. Yes. So, another draft physics presentation. I thought I would play some of these Michael van Biezen videos because they really get to this argument that you can't just understand things mathematically. You have to understand them conceptually, and he attempts to blend concept and math. And I think is apparent, especially when he was doing other. I mean, I like to play all the videos, but I just don't know if you're up to it as an audience. On all the particle zoo kind of videos, and so maybe I will eventually get to that, just because it just reveals how weak this physics is, in the sense that there's absolutely no citation to why they believe something exists, and if there is a citation to some sort of experiment that indicates something, it's incredibly weak, thin, it's a seems like kind of conclusion rather than any like hard evidence demonstrating it's actually what you think it is, what you've identified it as. So this is like looking at a fog, and you see creatures moving around, and you're trying to identify them, and you're doing it badly. You can't tell the difference between hippopotamus and baby elephant. And it's just the truth, and that's the weakness of mathematical physics. It's it's too abstract from the nuance and detail that is the reality. This idea of turning a frequency into energy is just wrong. Momentum is energy, and momentum is more than frequency, it's volume. And it depends on what you're trying to do. See, I mean, this equation works if all you're trying to do is measure how much electricity you get out of a system. But it doesn't work if you're measuring how hot does it get and how all these other things does it get. It doesn't account for real energy. So anyway, so this is related to a comment. My own truth, whatever that means, with vague, indecipherable icon. I gotta find out who this guy is. I mean, what videos he's interested in. You use mathematics way too much. You use mathematics way too little. So the argument is somehow I have to use mathematics to explain conceptually what an elephant is. And I really don't. I can just draw you a picture, and I can explain the ears and the trunk and two eyes, and I can go through all the parts and explain the thing. So I don't really have to use mathematics. I mean, I can explain a car crash. I don't really have to give you any mathematics for you to understand concepts. So yes, once you understand something about motion, I can say that a car is going 50 miles an hour, and it's going to crash into another car going 50 miles an hour. Two cars that are about the same size, and we could make predictions, and I don't need to do any heavy amount of mathematics to predict that, a lot of stuff will go this way. That these two motions will end up getting combined in this little area. They will bang into each other and share each other's pressure, and a little bit of rub off of a little bit of this will rub off on a piece of that, and then they'll hit again, and a little bit of this will rub off on a piece of that, and they'll combine each other's motion and create a new motion. Now, I don't need mathematics to tell me that's going to happen. It's not integral or essential to understanding the concept that this is a motion, that it has a vector, and that this is a vector, and do it without. I don't have to have v of 1 and v of 2 and v of 1 and v of 2 and do all that. I don't have to do any of that crap to understand it. And I'm certainly not, as I've pointed out, I'm not disputing math. I'm not disputing Pythagoras or something. I'm not even disputing, in a sense, Maxwell, beyond making the point that there is no permutivity of space or permeability of space, that those constants were completely made up. They didn't go out in space and measure the constant. They didn't measure some constant that turns out when you multiply the two and divide by the square root or whatever, you end up with the speed of light. That didn't happen. They didn't discover something that's half the speed of light and something else that's half the speed of light. No, they created mathematical equations that were incomplete in the sense that they weren't accounting for the fact that there's both electricity and magnetism by their understanding, and that the two had to always be added up to a complete picture, and that's why you needed these two constants. But you don't need the two constants, because the two constants are really representations of one constant. But again, you won't answer any of my questions, right? I mean, I've stated that math is just a formalization of what we already know. We observe something, we observe this relationship, and we can turn it into mathematics and understanding that this has motion in one dimension, this one has motion in another dimension, and that dimensional motion can be translated into a third motion, okay, that's going to be based on averaging it out, a combination of those two by how much time they have to mix. So the faster they're going, lots of things will decide exactly how much of the mass will end up going in that direction. So yes, you can write a mathematical equation to explain what you've already observed. It's a formalization, it's formula. It's taking something that you have observed, a relationship, the slit does something. If I make it narrower and wider, I watch it, I see it do it, and then I write a formula to describe what it's doing. That's not exactly telling you something you didn't know. So, so this is just, you're just saying that physics is math. I'm saying this isn't math. Okay, a car going this way and a car going that way is not some mathematical equation. They're real things, real events. The fact that it's a deterministic universe based on elemental functions, yes. But do you think they've gotten to the elemental functions? Do you think the permutivity of space or the permeability of space is an elemental function? So my argument is your math is incomplete at best. And at worst, saying momentum is frequency is just plain wrong. Okay, that's just wrong. All right. Math is important if you need to know the exact answer, but that's it. It's only for knowing the exact answer. I don't know if that's an exact quote. It's not understanding concept. You don't need mathematics to know what's going to happen. Again, you really don't. You've seen it happen before. You know the same rules apply. It's just deduction. Somebody debunked your theory on how redshift of background radiation happens by using mathematics. You say they did. That's all. There was nothing about the math I was challenging. So again, you're wrong again. It was just a question about whether or not the fact that something has motion in this direction and something like a photon interacts with it, whether in theory the frequency can be changed. And yes, I was wrong to say the frequency could be changed by that event alone, but I'm not wrong in the sense that the phase can be changed. And that's really all you have to do to break the photon. So in a sense, it turns out I'm right, in the sense that if this really did happen in the universe, and photons are as I say they are, which we might as well get to because we're going to talk about photons, if they are something that requires a frequency, that's the primary function of the photon, is to transmit a frequency, and the frequency has to be a volume to be recognized by something as an input device. You need to swing a pendulum, okay, and you have to get the pendulum this high. And if you don't get that high, the action isn't going to happen. Okay, so you have to swing the pendulum that far. And the only way you can swing the pendulum that far is to hit it 3 times. So if you hit it 3 times fast, okay, it goes here, here, and then here. But if you don't hit it fast enough, okay, then it swings back before the next interaction, and therefore your 3 is a waste. So if you have too big a gap between one of your hits, you won't reach this point. Now you're saying that's math. That can only be understood mathematically. I'm saying, you can understand it graphically. That the universe is graphic. That the universe is in fact made out of straight lines, then things moving them, and then it's things moving back and forth, reflecting, and that things are moving in patterns, and that's what the universe is made out of. And I don't need, okay, to know extensive manipulation of mathematics to understand that there's triangles inside of this square. Okay? I don't need to do that. I can see it, and I can see the relationship between sides. I can see lots of things without having this a bunch of formalizations. I can understand it conceptually. So, you know, this is so bogus. So, yeah, explain the useless point. Teabagger guy, I'm glad he changed his name to Lewis something or other, but he's still off the subject. I mean, the subject isn't. I haven't quit smoking in the sense that I'm still a nicotine addict, but regardless, whatever. Just try to understand that I don't need somebody to report on, you know, how blue my eyes look today. It's really just not the point of the channel. Alright, so let's see who this guy is, just for curiosity. Well, look at that, he has one of my videos on his playlist, so isn't that a surprise? Be subscribed to Puro. I mean, that's pretty much a waste of your brain space. So it must be just a troll's account where he just keeps crap that he wants to do something with at some future date or some kind of bullshit, I guess, I suppose. I don't know. These don't look like great channels. Oh, except for Glenos. Gray, 3 blue, 1 brown. Yeah, so that's a purely mathematical channel. Crap physics, frankly. But anyway, way too strangled out of any comprehensibility. Alright, so we'll play some of this, and probably need to draw in the future. Well, maybe I'll pause and clean the board, but I'll wait till we play a little of this crap.
Continuing our series on particle physics, we're now going to take a closer look at a few particles, one of them the photon. So let's start with the photon. Now, the photon is actually a really mysterious particle, even though it's ubiquitous, it's everywhere.
Right, so they concede it's mysterious, yet they make emphatic statements about what it is. You know, it's a wave, it's a this, it's a that. So, you know, there's no consistency in this argument.
The whole universe and everywhere around you, it's filled with photons. So what is a photon?
Right, so if you concede that point, that it appears like this crap is everywhere and that we can't detect some of it, you know, some of it's in these forms, radio waves, all these other frequency forms, and then you realize, you know, there's one more realization, not that there's a bunch of it in different frequencies, but there's also some of it that's in ray lengths, you know, 1, 2, 3, that 3 thing, it's only in 2s. See, the truth is the pendulum needs, for like our eyeball, the pendulum needs 9 hits. You know, it needs to be hit 9 times to get to a position where our mechanism says photon. Now, some other crystals of metal or some other crystals of stuff will, you know, do the right bulging with a lot less hits in a row. But that's the truth of it. And so anything that doesn't come at the right phase, we can't see either. And so that's an important thing to understand, is there could be a whole lot more radiation that's hitting things. You just can't in some way detect it because all it has to do is be a little bit out of alignment and you don't see it. Just a fact.
Well, the way to understand a photon, what it really is probably taking a look at various aspects of how photons interact with other particles, how photons exist.
So again, it's this inability to recognize that photons are fundamentally different. They're in a fundamentally different class than other particles, in the sense they're moving the speed of light. And the only things that move the speed of light are what we think of as forces. So the magnetic force or the electric field or whatever these stupid things are. Right, so the simple argument I'm making is they have 4 different forces. And they have even more when they do their particle physics, because now they have to create a field for every single particle. So there's 400 fields, which is just ridiculous. And who knows how many forces in those fields, right? Because each one of those fields is affected by a new force, a different force. But anyway, they have the strong, the weak, the magnetic, electric, and gravity. And, you know, those you can just argue that those four things are not four different things. It's all one mechanism. It's all dictated by this stuff moving the speed of light. So that's the momentum carrier. That's the thing that's, don't need to really point over there, I guess. That's the force carrier. The carrier is something like a photon, a bit, a quanta of momentum. And again, instead of recognizing that what it really is, which is little bits of momentum traveling, and if it has a frequency, it'll move our pendulums the way they need to be moved. And if it doesn't have the right frequency, it won't do what we need it to do. It won't overcome the elasticity, the inelasticity, the fact that the stuff is going to move back to its position if we don't hit it fast enough. And that's the simple principle. And there's no rational, in my opinion, counter argument to that better model. Understanding that it's one force, not four forces. The four, and again, and they'll even talk about four forces in one context, and then, you know, they believe that the one force is somehow a bent geodesic and the other force is some sort of virtual photon, which doesn't make any sense. I mean, these are obvious flaws, and you know, this bizarre effort to keep saying this isn't just a religion. They're reciting out of a Bible. They've created characters in their religion, you know, Holy Ghost, you know, these imaginary permutivity of space or some other bullshit character, and then they have to give them functions. And so yes, when you take 1 million people and give them 100 years to play with a silly story, they'll come up with a very elaborate role for this little Holy Ghost to play. Oh, the Holy Ghost keeps Jesus from giving the store away, and you know, God controls the Holy Ghost, and so it ends up like some rock, scissor, paper bullshit. So they can make this stuff fit into some kind of narrative, but the narrative is fundamentally flawed, unevidenced, and purely imaginary, in the sense that it doesn't really have much correlation to any real facts.
They do, how they share energy and so forth. So after a few more videos, including this one here, hopefully we have a better idea of what a photon is. So
yeah, you'll demonstrate it with very little evidence and any argument made, and there certainly won't be any requirement for there to be consistency. Particle wave duality, it's a non-starter.
Some basic things about photons. First of all, a photon is a piece of energy or a chunk of energy. The energy that's being exchanged between any object in the universe and any other object in the universe is done so by sharing photons, by sending photon from one to another. And we'll
so there, I mean, it's a perfectly agreeable statement that is rational physics. I mean, it's rational to understand that it's the force carrier is basically just saying I momentum. Okay, if I'm going this way, I'm going to hit something, I'll move it that way. And if I'm going this way and I hit something, I'll move it that way. Okay, and the real subtlety is, how does it move it? I mean, does it hit something and then stop? No, we kind of know it doesn't do that. So it must sort of jump into whatever it's going to move. And then the question becomes, well, doesn't the thing it jumps into gain mass or change if that's the way it was doing it? And so maybe you have this idea that it jumps in and some piece of the thing jumps out, and so it always stays the same. Electrons are all the same whether they're moving or not moving. They only have so much stuff in them, so many rowers in their boat, and that's all there is. So I'm just saying you can simply diagram this. Okay, I'm not disputing any of the math fundamentally. I'm saying yes, okay, E equals HF will work if all you're after is, did it produce electricity? But if you're after more than that, okay, that's underdone. That's understated. That's not saying enough about the fact that volume is real. So if I have the infrared light on for an hour and I have the ultraviolet light on for 4 seconds, I'm clearly going to produce more energy from the infrared hitting the surface. There's going to be reactions that will be real, both in terms of reflections and absorptions of heat. And it's just nonsense to say, no, the ultraviolet automatically wins the race. No, of course it doesn't. Volume matters, and volume is all you're really talking about in the end, is how much of the volume went from one place to another, how much real momentum, and then the only question is how much of the momentum was transmitted into real action. And that's it. It wasn't wasted as heat or converted into something else. So you can go back to sound or anything else. I mean, if you're creating the sonic boom, how much of the energy is actually wasted in the sense that it doesn't get released as movement of atoms in a coherent manner, it gets released in some incoherent pressure on surfaces.
Get into that in just a moment. So it's really a piece or a chunk of energy. Secondly,
so he says this thing, and then they'll just throw it out the window and start doing this crap. No, it's a movement, it's a perturbation in a field, it's it's the permutivity of space, it's some other kind of horse shit. Sorry, some other kind of garbage.
We can say that a photon has no mass and it moves at the speed of light.
So again, this idea that it can't have a mass, they'll change that to their discretion. So if when they need it to have a mass, they'll pretend that it gains mass from its momentum. So momentum is automatically a mass gainer, but it has no rest mass. That is, if you kept it not moving, it wouldn't have a mass. But they clearly give it a mass in the equations, something less than 0. So it doesn't mathematically come out to 0 because they know it has real momentum. So they give it an arbitrary, infinitely small mass merely to say its velocity is its mass, because in most circumstances, like in gravity for example, velocity is all that matters, not your mass, in terms of how the gravity will affect you.
So whatever it is, there's no mass. You can put them on a scale. Well, actually you can, because they can only exist if they move at the speed of light. So you can't stop them and put them on a scale and weigh them, but they still...
Yeah, so all you're doing is weighing their velocity. Because, and frankly, that's all you're doing when you're measuring the weight of a human being or anything that has mass. You're measuring its ability to produce photons, essentially, as reflections, as how much of the universe are they able to reflect back at you and create pressure. And that's all you're doing. So when an electron is opposing another electron, it's opposing it because there are actually these little force carriers bouncing back and forth, and the closer they get, the more that pressure builds up, and that's the pressure that makes surfaces. That's what makes atoms have any integrity, is the very fact that it has that stuff trapped between it.
Don't have mass. So no mass, they move at the speed of light.
So again, a statement that's just totally unnecessary, right? There's absolutely no reason to say it has no mass, because mathematically you'll give it mass. So why are you saying one thing and then doing exactly the opposite? Because you know that you can't say it's bent by gravity unless you give it some sort of fake mass. You have to give it mass or it fails in the mathematical equation. The mathematical equation will say there's no bending because there's no mass. So why play this game that you're saying it has no mass? It clearly has momentum. It has no mass. When it's going this way, it has no mass going this way or going that way, and it certainly has no mass going the opposite way. So in some dimensions it has no mass. You can't push on it because you can't move anything fast enough to push it, so you can't feel any mass. But doesn't mean it doesn't have momentum, and that's the real thing that mass is made out of, is how much pressure can you produce. That's what you're measuring.
A photon acts like a particle. It turns out a photon can hit another particle like an electron or a proton or something and actually bump it like a billiard ball.
Right, so it's not like a billiard ball would be the argument. Clearly the billiard ball transfers its momentum and the billiard ball stops. So if I hit another ball with a cue ball, the cue ball stops, the other ball takes all of the velocity and goes in some new direction. Photons aren't doing that, so that's wrong. So you have to have some other description of the pure kinetics. The pure kinetics have to be something like, no, the photon goes in, something else goes out, and now that momentum is shared in the electron, and the electron changes its direction. Now the electron doesn't get hit by a photon and move the speed of light. It moves some percentage of the speed of light per absorption of momentum in a direction. So just like a school of fish, if I'm going to add some new fish to the school, the idea would be I can't, because the school has to stay a certain size. So if I put 10 new fish in, 10 old fish leave, well, the 10 new fish have a direction, and the 10 old fish had a direction, and so clearly I'm changing the direction of the school overall because I've changed the direction that I'm adding. And adding and subtracting, which is an important difference, and it explains why electrons don't travel very straight. Explains lots of things, but again, they just preach out of this Bible, and they just don't have any willingness to say, well, maybe we draw a few wrong conclusions here. Maybe we've made some statements that aren't quite complete and aren't quite accurate, and there's just no willingness to concede anywhere in this recitation of what God says.
Pumping another billiard ball and making it move. So photons do have properties that make them look and act like they're particles.
So again, yes, but if physicists shouldn't fall for this look like, seems like, they have to demonstrate is like. The is like has to be demonstrated by evidence, and the evidence is first continuity of your theory. It doesn't produce these contradictions. You don't end up having to say something like virtual, or you don't have to say something so like wave-particle duality. You don't have to say something like destructive interference, as if somehow you can destroy the energy, which you can't do.
Even though they don't have mass. And as a particle, a photon has momentum.
There you go. So why don't you just quit playing a game like it don't have mass, when you know you can't write a momentum equation, you can't write a rational one that doesn't concede the existence of the mass. The mass is its momentum, the velocity times the mass is the momentum. So why are you playing this game that you can sit there and put frequency or some other notion in there and change that fact? That's the elemental function. The elemental property is that you have a certain amount of stuff, and you move it, and that's its ability to move something else. Is its mass, it's the number of quanta, and its direction. And so its speed is going to be a reflection of what percentage of it is moving imbalanced in one direction rather than another direction. And that's going to be your total, is understanding that the only percentage that matters is the part hitting you, the part heading your way. And there's a certain part that's always proportional. In terms of your motion is the byproduct of an imbalance. You have more rowers going this way than that way, then you go that way.
So just like when one billiard ball hits another billiard ball and makes it move, a photon can hit an electron and make it move. So that means it has momentum. Kind of interesting that a particle that has no mass actually has momentum.
It's not interesting, it's stupid. So that's where you should just stop and say, yeah, sorry, we didn't really fix this part yet. We're just playing with these old ideas, and this whole thing was just cobbled together, and that's a nail that's really in the wrong place, and it's going to put a hole in your foot eventually. So let's fix that. Okay, let's not spout that kind of nonsense. Let's fix it so we don't have to say something ridiculous. And they have no interest in fixing it. They'll just keep saying this stuff like, oh, isn't it fascinating? Isn't it interesting? Isn't it just a curious, bizarre thing that what I just said doesn't make any fucking sense? Excuse me. Any something crapping sense.
And finally, we can say that the energy of a photon is quantized. So each photon has a certain amount of energy, and it's a fixed.
So again, the idea is that it's the same thing. All of these little bits, this quanta, is all the same stuff, and it's moving the same speed. So clearly, it all has the same energy. It's obviously all, and it just depends on what direction the energy is moving, and that's all there is. So all there is it's the same cue ball. So you can use the cue ball example, use the pool table example, and say, look, they're all the same mass. They're all, let's say, theoretically, when you hit one, it's always the same velocity, and then you have the same scenario. Then you have a rational scenario. And again, the only part I would say is kind of wrong-headed is not to understand that the transfer mechanism is the elemental one, isn't some sort of cue ball. There's no such thing as cue ball. There's only momentum trapped and momentum not trapped. Yeah, I don't think I need to draw that. I'll choose not to at this time.
Amount of energy, and it's proportional to its frequency. So we can say.
So again, it's only proportional to its frequency when you're measuring it by a specific mechanism, like how much electricity does it produce, or how much of the energy is transmitted to, say, through induction or through some other process that is frequency dependent. But otherwise, you're just discounting all the other energy because you're not measuring it. So there's a clear, I mean, you can't deny there's a clear relationship, okay, between frequency and total momentum if everything is kept the same. That is, if you have a per second way of analyzing how much energy goes from point A to point B, and you require it to be under some narrow circumstance. So this is another part of where mathematics kind of fails, is because none of the formulas come with the stipulations, what they've assumed to be the circumstance by which they're doing the math. But I mean, clearly, you know, it's not a huge insight into reality to say that if I have a fixed amount of time that I'm going to measure, and I have these two scenarios, right? So I have blue light and red light, that there's going to be more momentum exchanged. There's more momentum potentially to use in this piece of blue light than there is in this piece of red light. I mean, it's kind of just overtly obvious that you have, whatever, 40% more energy in the blue light, in the sense that you have 40% more bits moving the speed of light in the direction that you're going to hit something with. It's obviously more cue balls, okay, but there's nothing intrinsic about the frequency that changes the elemental values. So these values are the same, and the only thing you're really changing is obvious, that if you shoot all the bullets in 1 second versus waiting 1 minute, that it's likely you'll hit the same bird. Or it's likely, well, like I'm just saying, it's likely if you have some kind of elastic thing that you're going to attempt to bend, that you're going to be able to bend it if you hit it fast before it can rebound. Then if you wait an hour between bullets, then obviously you'll just keep bending it this much, it'll go back, you'll bend it this much, it'll go back, you'll bend it this much, it'll go back. So if this is how you're measuring energy, then yeah, this is required. You have to have this higher frequency. But there's nothing intrinsically more energetic about the quanta itself. You just obviously increase the amount per time. So I mean, there's a stipulation to the math that, you know, they don't make it clear that that's the stipulation. That's the only way this replacing momentum with the word frequency works, is if you understand that's the confine it has to be in. And they're not doing that. They'll take that F thing to mean momentum, and they'll put it in some other equation where time isn't consistent. And that's breaking the rules.
That the energy of a photon is equal to some constant times the frequency of the photon, the frequency of...
So some constant, all he's saying is that's essentially the giving it the mass component. So the constant, they don't have the mass component to make the momentum argument. So the constant is just telling you the constant is what one of those little bits is, and the frequency is how often they're coming. So now you have your momentum argument. Now you have something you call energy. Energy is just another way of saying momentum.
oscillation of the photon. All photons, as they move through space at the speed of light, they oscillate like a wave because they're basically...
So he just started the video by saying it's a particle, it's straight liney, you know, all this stuff, and now he just turned it back into a piece of mush, an unquantized whatever this is.
A piece of a wave and a particle. Wow, well, we'll get into that a little bit more later.
No, you really won't, because there's no way to make it rational, so you evade it.
Now, H is a constant. It's called Planck's constant. It's named after Planck because he did a lot of research on subatomic particles like this. And the...
Well, we just know that this number doesn't have to be this number, only if you understand what quantity you're measuring it in. So it has to be under this restraint of saying, oh, is that the number if it's joules, or is that the number if it's a newton, or if that's the number if it's a foot-pound. I mean, it's a different number depending on what, whatever you call that, designation of the quantity. I don't know. What is irritating getting old.
H, the Planck constant, is equal to 6.626 times 10 to the minus 34 joules per second. Wow, that's a very small number. Now, since the speed of...
Right, so each little bit is a tiny bit of energy. But obviously there's a lot of those little bits, so they can do a lot of stuff and get up to megawatts of effect.
Of light is equal to the frequency times the wavelength, or the velocity of any wave is equal to the frequency times the wavelength. We can write the frequency as the fraction of the speed of light divided by the wavelength. So instead of writing h times f, h times the frequency, we can write it as h times c over lambda. So
which is probably better, because at least now you recognize that the speed is a constant, and you recognize that the it's now a time rigid formula, in that there's a Planckness to time, and so you're measuring this as a quantity of time and momentum, speed. So now you have speed and time in the equation, which makes more sense.
Let's do a little calculation. Let's figure out the energy of a typical photon coming from the sun, which has a wavelength of about 500 nanometers. On average, of course, there's some that have longer wavelengths and some that have shorter wavelengths. So let's say a typical photon where the lambda is equal to 500 nanometers, and the nanometers 10 to the minus 9 meters, so that would be 500 times 10 to the minus 9 meters. And let's go ahead and plug that into the equation here. So does this equal to 6.626 times 10 to the minus 34, that's joule.
Yeah, see, this is the part that, I'm sorry, gets a little bit tedious, because it's just writing very long constants to actually come up with an answer. Again, which doesn't tell you anything you can't already surmise once you've drawn a picture of it. I mean, once I see, oh yeah, there's 6 of these, there's 5 of these, and only 3 of these for the same distance. I can figure out that, oh, this is going to be 30 times more stuff than the other thing.
Times seconds, multiplied times the speed of light, 3 times 10 to the 8 meters per second, and then we divide that by the wavelength, which would be 500 times 10 to the minus 9 meters. Now for that, of course, we need a calculator, and let's see how much energy a typical photon from the sun has. So 6.626 e to the 34 minus.
So understood. This is just saying in one moment of time where both conditions are the same. That is, you don't have more of this, you don't have any gaps in these. So if you have the same amount of time and they're a continuous frequency, then it's true that you can say how many bits are in one of these things. But that's just kind of obvious. I don't need the math.
Times 3 e to the 8 divided by 500 e to the 9 minus, and it looks like that is equal to let's call it 3.98 times 10 to the minus 19 joules. That's not a lot of energy, but of course photons are pretty small, and there's a whole lot of them coming from the sun.
Right, and if I wanted to figure out, well, what's 400 nanometer light or what's 300 nanometer light, all I have to do is draw a picture like this. I find the relationship that's 5 to 3. I find the ratio, and I just multiply that by that decimal. And I can find any other frequency I want to find by just understanding how many are in the same quantity of time. So there's lots of, like I said, this is just geometry in a way. I mean, it all comes down to geometry and algebra, you know, Pythagorean kind of notions. And yes, these formulas are more efficient maybe to doing some things, but they're not more efficient in giving you the understanding that you can obviously see the relationship is 5 to 3.
Single second. Now, that number is so small that we like to sometimes convert it to electron volts. And so the conversion factor, so we would multiply it times 1 electron volt divided by 1.6 times 10 to the minus 19 joules. So the ratio between electron volts and joules is the same as the single charge equivalent to a coulomb, 1.6 times 10 to the minus 19. So if we divide that number...
And none of those things actually have any user-friendliness in terms of appreciating them. So until you put them into something like foot-pounds, you know, like a Newton is like 50 foot-pounds or something, you know, you have to have some sort of, you know, I mean, yes, there's people, no doubt, people who do this all the time, they have those already built in. An understanding of what the difference between a coulomb and a Newton and a watt and a horsepower and all these different ways of measuring the same thing. But this is another flaw in their physics that just makes it very un-user friendly, is to have 15 million different ways to describe E. You know, E isn't in one form, like E equals how much pressure, and put the pressure in some sort of understandable jargon.
By 1.6 times 10 to the minus 19, we get 2.48. So we get 2.48 electron volts.
So you could argue that this is how much energy it takes to move one electron, one Planck constant of distance or something. And so you could say a photon has the capacity to move it at something like whatever, 40 miles an hour, you know, something like that.
So the energy in a typical photon coming from the sun is somewhere between 2 and 3 electron volts. Average is about 2.5 electron volts. That's the energy of a single photon. Now, the intensity of electromagnetic radiation, and basically what a photon is, an accumulation of photons is...
Yeah, so there you go, the accumulation of photons. So that's volume. That's all you're going to say, is that each quanta, each bit, has a standard ability to transfer a standard amount of momentum, and all you're really saying is how many are there? And if they're in the right shape, then they'll be received to create electricity. If they're in the wrong shape, it'll look like there's none. Now you can know they're there. We know all this other radiation is hitting us. We don't feel it because it doesn't create the same kind of action that, say, getting hit by infrared or ultraviolet or some other kind would have. So because it doesn't cause the physical reaction, my skin doesn't start to boil or something, I say it doesn't exist. Well, it does exist, it just isn't doing anything. The radio waves and all the other stuff hitting me isn't doing anything I can sense. But it isn't not energy.
Electromagnetic radiation. So you say, okay, how can that be? Because isn't electromagnetic radiation kind of like a wave, a change in electric fields that move through space? And the answer is yes.
It says you, right. So this is the part they say, yes, isn't it this? Although we don't have any experiment I can point you to say this is what it's doing. There's just nothing. All right? It doesn't exist. And it's just their metaphor for frequency. They've decided to create some magical field that somehow perturbates or vibrates or permutives or whatever the activities in some way. But it's completely superfluous. It serves absolutely no purpose to their own math. It doesn't exist as a useful function. The only function that matters is how many quanta, how many clumps of momentum, at what rate landed on a surface. And that's the only part that's going to matter. None of that wave crap is ever going to mean anything. None of the sinusoidalness of it could possibly mean anything. All it's going to mean is a clump, a clump, a clump at a distance. And that's it, at a rate. So this is where it's just failure. They can't even describe their own mathematics rationally, because their mathematics doesn't contain this useless sine wave.
But that's actually broken up into small little chunks, which are called photons. So
again, so he's using the word photon, right? And he's saying, like, just as I do and try to describe this, you end up calling these little bits photons. And that's wrong, because the photon is only going to be recognized by a surface as a frequency. So obviously you can say right away that the only way it can be recognized as a frequency, there has to be at least two of them. All right, you have to have at least two quanta of photon. All right, and in most cases it's many more than that you need before you're going to create the proper response in the crystal of the metal. You're not going to bend the trampoline, okay, unless you get a number of these. So it's so incomplete as a theory, as a statement about reality, and it's based on nothing. The fields are only used as a placeholder for saying quanta, for saying bit. Maxwell's equations don't have the bit in them. That's their problem.
Photons are basically chunks of electromagnetic radiation, and together in unison they form electromagnetic radiation.
So again, together in unison. No, the only thing that's going to matter is the fact is that you can take the phase and match two different sources, can hit a location and create the frequency you need to say photon, to get the proper number of hits in the proper order. So the bits are the functioning element, and you can mix a whole bunch of photons together and they will have the combined result of having the right frequency.
So we'll look at that unison a little bit more in a future video here. So let's say here we have the sun, and the sun shines, and so therefore electromagnetic radiation is leaving the sun.
Yeah, so what's leaving the sun? Is the quanta leaving the sun? Is the bits at a frequency leaving the sun? Or some stupid nonsense about a bunch of individual little wavicle thingies moving like they were rays? Or is it one big giant sea of wave? So that's the argument. So if you understand it's these little bits at a frequency, then you can understand they're emitted from different locations, that their phases will be different when they reach a location, because the distances are going to be real differences. The sun is round, let's say. The photons coming from one part of the sun will have to travel a longer path to get to me than the photons from some other part of the sun. So their phases are going to be different. And through the process of mixing, the photons themselves, the emitter, the crystal that emitted it, is emitting it in this very wide thing, this thing that's nanometers thick, hundreds of nanometers out of alignment, and it's going to hit a surface spread over many electrons, many atoms, let alone electrons. So obviously the energy has to be combined by the surface. If the photon itself is bigger than 20 atoms, you can understand that the photon can't be interacting with one electron. It has to be interacting with multiple electrons, and that other photons are filling in the gaps.
And in a way, what is happening is we have single photons leaving the sun altogether, forming that sun.
So again, it's single quanta, so you have to have some other word. Again, he's using the word photon, kind of saying these single little bits, the single little quanta, are leaving the sun. And the fact is as they leave the sun, they'll be inside of that mess of little bits, those stones flying through space. Inside of that mass is going to be places where there's where they have a frequency, where they're at the right distance between each other, and one from one place is going to line up with one from another place and create the fastness necessary, the quick hits in sequence, without any breaks, the 9 hits the trampoline needs to get it deep enough to hit the bell, so to speak. And that's all you're going to decide is did you send enough stuff, and did enough of it hit one location without any gaps.
Light, that electromagnetic radiation. So the intensity of electromagnetic radiation or sunlight can be written in terms of watts per square meter or joules per second per square meter. Another way of looking at it is we can say, well, how much energy is imparted by sunlight? And so by the time the sunlight reaches the Earth, the amount of energy deposited is about 1,361 watts per square meter. So that's the entire.
Right, so once you know that number, I don't know why he's going to bother with this calculation. That's the only part that's interesting. So that's what gets to the atmosphere. What gets to the surface might be 900 watts per square meter, which is gives you some idea of the challenge of solar energy, because it's really not that much for a square meter. So, it's a challenge to be able to collect all of it. And even if you collect all of it, it's not that much energy.
Intensity of sunlight, and so again, it's in watts per square meter. So how many photons is that? Wow, well, since each photon carries this many joules, and the intensity is 1,360.
So again, he said each photon carries this many joules. That was the momentum, that was the value for one quanta of the frequency, one Planck bit of photon. So it's not, that's like saying, well, let's just erase this frequency and just talk about these bits, when you can't really do that and measure it. You can't measure this. So, it's sort of completely dependent on the existence of it being at the right frequency. If it's not at the right frequency, you're not going to see it. You're not going to be able to measure it, because it's going to look like gravity, and there's a ton of gravity. So you can't measure the amount of photons that are, let's say photons are gravity, the same thing. The little quanta are the gravity. Obviously, the massive amount of gravity that's hitting the Earth to move it, an insane amount of force, because you have this imbalance between the sun and the Earth and the other side of the Earth. Blah 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 blah. Anyway. So it would be like detecting, I don't even know how to make an analogy to how tiny the difference would be from even 1,000 watts of photons is a tiny amount of energy compared to the massive amount of energy the Earth is actually exposed to.
61 joules per second per square meter. Then how many photons of light reach the Earth for every square meter, or I should say sunlight, reach the Earth every square meter based upon this ratio? So if we want to calculate the number of photons that reach the Earth, so the number of photons.
So he's now just going to basically tell you how many photons are in a watt, because he has a number, and so now he can use that number and just dissect that number. And so I don't think this math is terribly useful, because it's like, duh. Once you've told me how much, let's say 10% of an elephant weighs, well, now I can tell you how much 100% of an elephant weighs. I mean, it's not very challenging.
Per second per square meter. So sunlight reaching the Earth will contain 3.42 times 10 to the 21 photons for every square meter surface.
So when he says photons, he doesn't mean photon. He means quanta of photon, piece of photon, element of photon. So he means one of those waves. If you were to dissect it, one of those from peak to valley, or from peak to peak is where you'd measure it from. One clump of frequency, one clump of wavelength, one clump of photon.
That's an enormous quantity of photons. Just imagine how many photons actually leave the sun in every given second. So that 93 million miles away, when it reaches the Earth, 1 square meter of it contains that many photons.
Yes, but it's in, let's see how to say it. that's just the, I've already said it, yes. You're just counting this part. You're just saying how much is in 1 second of time, one tiny moment of time, what's the number. But you haven't decided whether they have any frequency at all. So you're going to have a lot more than that, because the only stuff you've measured, the 1300 watts, was how much of it can I convert to electricity? How much can I collect as heat or electricity or all the stuff we know of? So he hasn't really counted the right number, because the first number, the 1300 watt number, wasn't right, because it wasn't a reflection of what the actual number of those things were. It was a reflection of how many of those could I count. How many of those could I collect as true photons? That is, having the frequency that was necessary to move the crystal. It wasn't how many hit the crystal, it was how many moved the crystal enough to create the electric current or to create measurable heat.
Absolutely amazing. So again, what is a photon? Well, we're not quite sure yet.
Yeah, but you're so sure that you're right, that you have this whole theory of 400 different particles, all of this crap. You're quite confident it can't be assailed by anything. It can't be changed. Nobody's allowed to say that doesn't make any sense. It sounds like woo. It sounds like BS. Nobody's allowed to question it. And yet you concede, well, you know, yeah, our model does seem a little bit silly, incomplete. Yet we don't want to hear about how to complete it.
Based upon this, but what we're going to do over this video and the next several videos is zero in on how photons interact and slowly try to form a picture of it. We'll look at how photons scatter in the atmosphere. We'll look at all the various experiments that we've done to identify photons as much as possible. And based upon that, I think we'll form a pretty good picture.
Yeah, well, I would disagree. And even subjects like scatter, you know, they'll talk about scatter that only has to do really with X-rays. There's no other scatter involved except what X-rays do. So again, now we're back to how it affects, how specific materials are affected by specific forms of the energy, specific arrangements of energy. But it's not some generic statement about what photons do. It's about what specific interactions will cause. Like having to blow into a flute the right way, right? If you're blowing into it any old way, it ain't going to work. You have to blow into it a specific way for it to work. You have to create the frequencies that create all the other frequencies. You can't make a frequency without putting a frequency in, essentially. You have to vibrate it just to make it harmonically vibrate. I mean, these are the real rules. And those same rules apply to this little elemental stuff, because it's basically completely dependent on tension. It's not vibrations I don't think in any real sense. I mean, a vibration is not a vibration. A vibration is a trapping of energy. So you put energy in, you make a box and you put energy in. And what happens when you do that? What happens when you put energy into this box with two sides and the energy can reflect perfectly? What happens? Well, what happens is this went in as a +1 in this direction. Okay, you added this. When it goes back and hits this back wall, well, the back wall is number one going to be closer. Okay, so it's going to happen quicker, because this reflection is going to, the distance is being shortened by the movement of the box. But what's going to happen when it hits? It's going to just do a -1. It's not going to make you go backwards. It's just going to stop your motion. So now you're going to go forward, and then you're going to stop, and then you're going to go forward, and then you're going to stop. So you're going to do a bit thing. You're going to do a 0, 1, 0, 1. You're never going to do a -1. So the box will always move, and it's going to move in this jerky fashion that you could call a frequency. And that's your harmonic. That's the thing. That's its motion frequency. And depending on how fast you make it go, that frequency will change, and it'll be a quicker little dotted line. So the more momentum you give it. Now, it just happens that this also is a mechanism for overcoming drag, as I've explained. Because of this fact that you're shortening the distance. So you make the distance it has to travel less as you create more drag, which means the two will overcome each other. They'll be inversely related. So the more drag you get, the shorter the distance. So the quicker the reaction, which means more velocity. So you can't, the drag is zero in its effect. But it's a very simple mechanism, right? But that's essentially what's being argued here, is that any of this frequency component just has to do with this idea of a swinging pendulum. It just has to do with the fact that the initial motion is always conserved. You always conserve what you threw the thing into the circle with. So the energy you did this to make a circle means the circle just keeps processing. The initial what went in is conserved, and all you do is undo everything after that. You don't undo it itself. You never get the -1. There's no way to get the -1. You threw it in this way, that energy never dies. It just gets suppressed for a moment, and then it happens again. And then it's suppressed, and then it happens, and then it's suppressed, and then it happens. So everything gets converted into this pulsating idea, but the pulsating isn't the elemental function. The momentum is the elemental function. Alright. Oh, I have more to go. Yeah. I thought the video was over.
Another way that we want to look at is, we know that all matter in the universe contains energy in the form of heat, and heat is really the kinetic energy contained in the vibration of the atoms in that object.
Right, so that's only one portion, though, of its momentum. The argument could be made that the photon already contains energy inside of it, and you can balance that energy, keep it in one place, by having, it has seats and it has rowers. And so it has energy in it, but we don't have a way of deconstructing electrons. And the other part would be is what's in the sea around it. So yes, if you could take all the swimmers out of the sea, then there's nothing to move the boat because there's no swimmer to jump in and replace some other swimmer. So there's no way to change its momentum. But that's all you're really saying is I'm going to take a system and keep it balanced. Now you don't know how much energy is in that system because it's balanced. It doesn't have any energy when it's in balance, you could argue. But it has a ton of energy. So mass is energy, because mass is the ability to be a boat, to make an exchange.
So any object, be it a chair, being a person, being an ice cream in the freezer, everything has atoms, and those atoms vibrate. The hotter the object is, the faster the atom.
So we're really just saying energy is the stuff moving. You could fill the whole universe with stuff moving, and if it's all balanced, that is, there's as much going this way as going that way, and it's all going to bounce in a balloon of some kind, there's going to be always a pressure going out. You can't evade it, right? I mean, the stuff going this way, it's always going to go hit that side, and then it's going to hit that side, and it's going to hit that side, and it's going to hit that side. And if you don't know which way it ever came in, or if it all came in equally, the same number of, I throw the same number of stuff in the box this way as I throw in the box that way, the box isn't going to go anywhere. Doesn't mean it doesn't have any energy. It just means you can't see energy until you create imbalance. You have to create a change in the pressure to see energy.
Atoms vibrate. The colder the object is, the slower the atoms vibrate. And as the atoms vibrate, they carry with them an oscillating electric field. And that oscillating electric field causes electromagnetic radiation to emanate from out.
So they say, right? So my argument would be it has nothing to do with the oscillations changing anything. Everything's a mirror. And if I move the mirror, I move what it reflects. But that's all I can do. It's still the same thing. It doesn't change its properties because I move it. Now, I can move it and therefore change the relationships to some other part of the atom or some other mechanism. And so then I can exchange them. If I'm moving, then I'm going to start causing other things to move, and the movement's going to spread. But it's going to be diluted. I can't keep my movement and give him movement. A cue ball can't hit the other ball and both balls move. All right? But the little force bits essentially can do that when they're interacting with something that has a supply of rowers. Let's see how to say it. Yeah, so it has nothing to do with any field being vibrated. What you're doing is releasing these little bits. So if I have two things and they have a little ping pong ball bouncing between them, I can change their relationship. I can move them apart or move them skewed to each other, and now I can release energy. But there'll be a consequence, and then the two paddles will end up being closer to each other. Something will have to change in the structure of something if it's going to produce something extra. And the rest of all it's doing is just reflecting what the world's throwing at it. And so that's what I would argue is the difference between a magnet and a non-magnet. A pile of atoms that are magnetized, a pile of atoms that aren't magnetized. A piece of steel not magnetized, a piece of steel that is magnetized. You haven't changed the energy at all. All you've done is changed the relationship of the mirrors. And now it's reflecting all the red energy one way and all the blue energy the other way. That's it. It's just a filter. It doesn't make energy.
Objects, and that's how objects cool. When you take a hot object like a hot brick that just came out of the oven, put it there on the table, the brick will slowly cool down as the energy radiates away from the.
So the energy is these little photons caught in between the atoms and keeps jiggling the atoms. That's one form of the energy. The atoms moving themselves is another form. So the ping pong battles are moving, the ball is moving. So you can cool it down two ways. You can try to stop the paddles from moving, or you can just get rid of some of the little ping pong balls that are causing the interaction to spread. The more balls you take out, the more settled the paddles will be.
Brick as electromagnetic radiation leaves the brick from the vibrating atoms.
Right, and the thing gets smaller. As it radiates the heat, it loses, in a sense, volume and mass.
It turns out that the frequency of the photons, because remember, electromagnetic radiation emanating from an object is really photons leaving the object.
There you go. So it's photons, it's these little bits, these little hunks of quanta, right. But it's not the only source of heat. So again, you still have to account for the momentum of the atoms itself, in the sense of the atoms can have momentum in a direction, and their momentum is dependent on the relationship of what they've got inside of them, and you have to apply a force to slow them down.
And the frequency of the photons leaving the object is equal to the frequency of the oscillation of the atoms, or the oscillating atoms. Wow. So how fast is that frequency? What is the frequency of a typical atom in an object like that? Let's say at room temperature, or let's say from a brick that just came out.
So the frequency is, again, just talking about how fast something, the virtual photon, okay, it interacts, how often it interacts. And how often it interacts depends on how close it is. So all you're saying is when you heat things up, the atoms end up closer together as a byproduct, in the sense that they have more interactions with each other because the little bits have less distance to travel. So motion means that there's more likelihood of closer interactions. Pressure, you're making more pressure by increasing the number of times the ping pong ball hits a paddle. How to say that? Because that's commensurate to energy. It's a form of imbalance. Let's see how else to say it. It's just more interactions. You're changing something bouncing this distance, all right, has a certain pressure it can create. A certain number of times it'll hit the side moving the same speed. If I move it closer together, I'm going to double the amount of times it's going to interact. And it's the interactions that define the pressure. So obviously there's going to be more pressure to move the closer I bring the two surfaces.
Out of the oven that gives off a certain amount of electromagnetic radiation. Well, let's say we have an object that, let's see here, let's take a photon again, the same photon, the yellow photon that has 2.48.
Okay, so the point would be is that you can add lots of energy to a system, that is lots of these little photon bits at different frequencies, and the point is that the atoms will spread the energy, so they'll neutralize it into one frequency. So as you're heating it, all the atoms end up vibrating or being bumped into each other at the same rate, because anybody who's going a little faster or has more momentum, that momentum will be shared by the other atoms, and so that momentum will dissipate. It'll even out. The fatness will go to the thinness. The high pressure will be blended in with the low pressure, and you'll end up with one consistent pressure, and you'll produce one consistent amount of frequency of the escaping bits will be leaving the surface, and it will be the surface they leave at a certain rate, because the surface is going to end up vibrating at a certain rate that's a blending of all the different vibrations that it might be made out of. The surface just translates what's happening on the inside. So you can have really, if you could change the speed of them, then you could understand you could have all kinds of different speed of things moving inside of something, and how much the surface as a whole moves will be decided based on averaging all that out.
Electron volts of radiation. So let's say we take a piece of metal and we heat it hot enough so it begins to glow visible light, so that it's thousands of degrees in temperature. And let's say that a yellow photon leaves the brick, or leaves the molten metal. So let's say that we have a yellow photon, and so then we know that the wavelength is...
So this is another thing that we are, again, this is just showing that these mathematical equations are just formalizations of what we've already observed. So we observe that it changes color as it gets hotter. We observe that the thermometer goes up, proportional to the change in the frequency of the light. Formalizing that is not explaining why it happens.
500 nanometers. So the question is, here, where did it go? Right here. Here's the relationship between frequency, wavelength, and the speed of light. So we know that the frequency is therefore equal to the speed of light divided by the wavelength. The speed of light is 3 times 10 to the 8 meters per second. The wavelength associated with yellow light would be 500 nanometers, which is 500 times 10 to the minus 9 meters. And let's see what that ratio is. So we have 3 e to the 8 divided by 500 e to the 9 minus, and we get 6 times 10 to the minus 14, not minus 14, to the positive 14 hertz, which would be cycles per second, or vibrations per second.
So again, that's now he's just converting the frequency, 500 nanometers, into into hertz, which is whatever, trillahertz or something. It was just not very useful.
Second. Now 10 to the 12th, well, that would be trillion. So 6 times 10 to the 14th, that would be 600 trillion. So this is equal to 600.
Again, it's not very helpful, but it just sort of helps in the sense that you understand how hard it is to make something vibrate at that frequency. So like the clock speed of a processor we make for a computer or something might be in the gigahertz. Getting to the trillahertz, that's going to be real work. Yeah, I think it works that way. Megahertz, gigahertz. See, they use these words and it's like, oh, that ain't quite right. So you go megahertz, gigahertz. Well, you should go millihertz or something. I mean, billahertz, something like that.
Trillion vibrations of oscillations per second. Trillion per second. All right, so we have molten metal, and it's so hot that it glows visible light, including yellow photons. The atoms would vibrate at a frequency of 600.
So all that vibrate means, again, is that you're bringing atoms close together. They have momentum towards each other, and they're ping pong paddling, and they're creating photons that are bouncing back and forth at a very high rate. So you're just really measuring the speed of the interactions and the average speed of the interactions in the substance. That is, what's the average number of interactions a single photon, the single bits inside. So how many, for each ping pong ball, there's a rate at which it's having an interaction. Some of them are bouncing between things that are far apart and going a great deal of distance between interactions, and some of them are having interactions incredibly quick because the paddles are incredibly close together. And all that number is saying is that the average number of interactions is this trillion scale. That is, and when you average it out, the average ping pong ball is encountering something every trillionth of a second. It's hitting a surface.
Trillion times per second. As they do that, they emanate electromagnetic radiation, so they emanate photons.
No, yes, they emanate this stuff. The little bits fall out, and that's why it gets colder, because the little ping pong balls fly out. There's too many of them moving, having too many interactions, and so it's very chaotic, and the system that would regulate that can't regulate it anymore because the atoms are moving too much, and they're full of electrons and protons, and all of that stuff is changing its relationship. And so it's going to radiate it until it becomes more stable. It's going to seek stability, and it's going to find it by just radiating the noise.
Now the question is, as it's vibrating, for every one oscillation, does it give off one photon? Is it two oscillations? Well, we'll get to that. But at least we know that it sends out photons. Those are particles of energy that then flood the region around it. If it's out in...
So he says particles of energy, and then he'll go back again and just say, no, it's this wavy thingy, whatever. It doesn't make any sense. The photon is not a single thing waving, clearly. The quanta is in the wavelength, clearly, by the frequency formula. It's basically telling you, and the Planck's constant is basically telling you per undulation there's a quanta. So it's not one thing oscillating through space. It's a collection of things, okay, at a distance. I mean, it's impossible to deduce it any other way just by what they already know. So why, like I said, he says it right one minute. It's a bunch of these little Planck constants of momentum released at a frequency. And the frequency is just representing the average of what's happening inside the material. What's the average interaction rate of one of those little bits when it's inside that box? And the truth is the average interaction rate inside the box, for a photon inside the box, is hugely different than a photon outside the box. Outside the box, the photon, the little bit, is having an interaction every 3 days, maybe. Whatever the average might be. And the ones inside the box are having one every trillionth of a second. And all that's going to happen is that the imbalance of that rate of interaction is going to leak into the place where there's less interaction, just by how uninsulated the atoms are. So the more atmosphere you have, the more radiation you'll leak. The less atmosphere, the less radiation, because the only form of escape isn't interacting with the atoms, but it's the atoms themselves breaking down enough to let a photon release, a little bit escape. So there's two forms of escape. There's escape that can happen in a vacuum, and then there's the escape that happens because you've filled the volume with some sort of substance that can actually vibrate the atoms of the new substance and transfer the pressure by vibrating the other atoms. If there's no atoms to vibrate on the outside, then you're stuck just releasing the energy itself, not the movement of the atoms. You can only release ping pong balls in space. In an atmosphere, you can dull the motion of the atoms themselves. You can take their momentum away.
In space, of course, it would travel for billions and billions of miles. If it's here on the Earth, it probably just travel far enough until it hits another object. That other object will absorb that photon, and so the energy then will be transferred from one object to the next.
So he really didn't get to the fact that there's a fundamental difference between what radiation you're going to emit depending on what atmosphere you're in. No atmosphere, you have to release ping pong balls. In atmosphere, the paddles can transfer some of the energy.
So now you have a little bit better idea what a photon is, but if you're still wondering, stay tuned. We have some more videos as we try to explore exactly what a photon is.
So again, he's saying he has the exact explanation, and I'm arguing no, it's flawed right from the source, right from the beginning. It's conceptually wrong. He has a few mathematical equations that are correct, but they're only correct in the context of understanding the context. Understanding that when you're saying photon, you're not saying photon, you're saying little bit, okay, of a photon, a piece of a photon. There's, you know, well, what's the point? But I mean, there's no logic here. There's no logical conversation available. So anyway, enough of a video. Hopefully I didn't go over and such and so forth and whatnot.